So we're here at IMTS 2022. I'm at the CGTech booth, and my name is Jeff Vagley. I'm with the Vericut product group here at CGTech. We're here talking about our CNC Machine Connect software that we have that we're debuting here at IMTS this year. We have two main modules that we're showing everyone this year. It's the CNC Connect pre-check and live monitoring. So what these pieces of software allow you to do is do a direct connection to the CNC machine, so you bridge that gap of not knowing what's actually happening down on the shop floor. So the first module is what's called pre-check. We've checked for the work offsets, tooling offsets, and the NC program, and we get a variety of lights. When we have green lights, that tells us that the data we had in Vericut matches what was on the real CNC machine. If we had red lights, such as what we have here with tooling and the NC program, then that shows that there's a difference that we need to investigate. If we take a look at the tooling offsets tab, we see that we've got one tool highlighted that shows a difference in the length. So if we want, we can simply update that from the real CNC machine, and that updates the data that we have here in Vericut. We have tolerances that we can use to account for that difference between the virtual perfect world and what's really happening down on the real machine, where numbers and dimensions are not always exact and perfect. So we also have some differences here shown in the NC program. So if we take a look at the comparison, we can see that we've got a difference here on this line, and it shows there's a different revision from what's on Vericut to what's in the real machine. So that should raise a red flag to your operator as well as your CNC programmer to have a discussion and possibly update that data. And you can see down here it shows that there's a difference with a subroutine. We can also see other differences if someone went in and did a manual edit to the program. You can see here on the left, we had originally programmed a feed rate of 100 inches per minute, but someone went in and made a change, and now we have a feed rate of 90 inches per minute. So I also want to talk to you about another module we've got, live monitoring. So here I've got a control sitting right next to Vericut, and we've got the control running an actual program, just simulating what you would see down on the real shop floor. So I can connect to that real controller using CGTech's data exchange software, and we can view Vericut moving just like the real machine is. So here we can see on this heads-up display, we've got a variety of information being shown, anything from the NC block number to various information on how the machine is behaving and working. We've got spindle speeds that are displayed, we've got feed rates that are displayed, and for example, if I take our feed rate, you can see someone turned it down to 70%. If I crank that up to 100%, you'll notice you get an immediate change that's displayed on Vericut. Same way as if someone would stop the machine with an e-stop, you can see we've now showed that the e-stop is engaged, the machine's not cycling, and if we continue and restart that, you can see we're back up and running, showing where the real machine is at. So the advantage of using these two modules is this bridges the gap of that verification world that you were at when you're at your desk to what's really going on in the shop floor. There's no more unknowns about what's really happening, and you can actually see what's going on with your machinist as well as where your machine is at and what it's cutting.
Hi, my name is Gene Granata. I'm the Director of Product Management for CGTech, and we're here at IMTS 2022 showing Vericut, our flagship software, and we will be talking a little bit today about the intelligence of cutting tools and how they help towards optimization. So what we have here is our latest release, Vericut version 9.3. And just like most of our users, I've just completed verifying this NC program to make sure the part is doing what I expect to do. The NC programs are good, but what I want to do now is optimize. So we're going to do this the easy way, and then I'm going to show you behind the scenes what happened. So to do the optimization, we're going to go ahead and kick this thing off, and as you see, the Vericut is going to be cutting the part, and we have the tools behind the scenes, and what's unique about this is these tools have intelligence with them. There's intelligence that talk about how these tools can be used, what are their limits, what are the proper feeds and speeds, and if you just look in the corner down there, you see we're cutting aluminum in this particular simulation. Vericut knows the material being cut, And with the tool information, the simulation information, we're able to optimize this part to mitigate excessive cutting forces, tool deflection, maintain the proper cutting loads for the tool. Each tool as it runs through the part. So here we've optimized a bunch of them, and you're seeing just a quick summary of the part. And this is telling us that we've saved about 21% savings in what you just saw. So even though that sounds incredible, it's just a number on the screen until you see how did this really happen. So let's look behind the scenes a little bit here. We'll open up Vericut's Tool Manager, and I'll show you the tools with the intelligence. So each cutting tool assembly that we would download from someplace like Machining Cloud, maybe Core Plus Tool Library, could be a tool repository or a data management system like TDM Systems. You get that information into Vericut, and it has all the information about feeds and speeds for the different types of materials that those tools cut. So these are tools that are intelligent. They know how to be used. They guide programmers how to use them properly, and they give Vericut the heads up for optimizing them in a way that no other system can perform. So what happened here? Let's take a look. So we have all the statistics over here in this area here, but we also have a wealth of information in what we call cutting graphs. These are the details of what happened with machining. If we just pick on a tool for an example here, and show that one, what we're looking at are several different things here. First, I'd like you to look at this red horizontal line. That's the target for that particular tool, or the limit for that tool. We don't want to exceed that. If I show you the unoptimized program, this is the original NC program. And you can see this top graph with the chip thickness, the hex value for that tool in this material. We've exceeded it with the cam-driven program that we put in here. And other areas you see we're well below that. Those are inefficiencies of the cutting tool. So we've got inadequacies, we're pushing the tool too hard. This job out on the shop floor isn't going to run super good. If we compare that then to the optimized program, what do you see? You see that the chip thicknesses are extremely constant. Every tool with its different chip thickness is held right to where it's supposed to be performing. This is what causes excellent cutting. We've got monitoring of the cutting forces, we've got feed per minute. There's all kinds of metrics here that we can choose from. This is the intelligence leads to smarter manufacturing. The view that we originally looked at shows the comparison of the two. And in particular, the tool that we were looking at, where we saw both inadequacies, we see now bright green, where optimization has raised the feed rate in order to get the chip thickness right where it needs to be. We see red, where the tool was being pushed too hard. We brought it down with the feed rate to get the chip thickness where it needs to be. So the end result is an NC program, a new one, with accelerating, decelerating feed rates, controlled by software intelligence and the cutting tool intelligence, and giving us an ideal cutting condition out at the machine. This tool is going to run longer, last longer, produce parts faster, and give us an ideal part with minimal involvement from the NC programmer. The intelligence doesn't need to be here, it's in the software and it's in the cutting tools. So that's what we were excited to show you. Thank you for watching, everybody. If you want more information, you can get it from cgtech.com.